All right. Hello. How are you guys doing today?
Doing well. Happy Monday.
Happy Monday. Yeah. Today's Monday. Yeah, that's right. Okay. So welcome to the last 280 SI project session. So congrats on getting all this way through the class. It's awesome. And this is the last component of the 280 project. I realized when I wrote this that I forgot to incorporate map into it. So it's a pretty small portion of the project, but after I go through the driver, I'll talk about map after that. So if you're watching the recording and looking for that, it's going to be at the tail end of that. So besides that, today's topic is going to be the driver. We covered the binary search tree stuff last week, and that recording's posted on the schedule as well. So in my opinion, this is the best part of 280. This driver's a lot of fun to make. It's very easy to debug as well. And honestly, it gives you a good introduction into like higher level CS classes and just programming with a purpose. So the main point of this driver is we are given a Piazza post. And this Piazza post is going to have some text associated with it, and it's also going to have a tag. So you know in Piazza, how when you go to make a post, you'll be like, how do I do this? And there'll be a category to select. You can select like P5 or midterm and stuff. Our goal basically is to have text available to us, and we want to determine from that text what's the best way to categorize this. And we basically want to see if our classifier works well or not. So before we actually get started with that, I do want to give like a few examples and give you guys some intuition on this. So if I gave you guys the post, how does the up card work? And I asked you guys, if I had to create a post for this, like a post label, what kind of category would I say it would be? Given this, how does the up card work? Does anyone know? Like, how would I label this? Given like the 280 Piazza?
Probably euchre.
Yep, exactly. So why do you say that?
Because up card was not in the other projects.
Yep, exactly. And that's the entire intuition behind this project. What we're doing essentially is we are looking at these posts and we want to analyze every word in the post. We want to ask ourselves the question, how likely is it that this word is going to be in this post? And we're basically going to take a majority vote. So let's say, for example, this exact post appeared in euchre. So how many times does the word how occur in the euchre post, right? That's the entire goal behind this. And today's session is dedicated towards like, how do we actually create structures to hold this information? How do we go about reading and training posts and then classifying posts correctly? So your intuition's absolutely right. We just need to build that intuition for our machine learning model. So before we get started, is anyone confused about the objective of the driver?
So like, would we be given like a sample post and then we would need to assign that to a label?
So what's happening here is, I'll go into that. It's a great question, actually. So basically, we're given two files here. The first file we're given is called the training set. And the training set gives us posts. So it'll give us a post, right? A post has a couple of things associated with it. The only thing we're really concerned about for this project is the content and the label. And I believe they call it tag. So I might call it label, but they mean the same thing. So tag or label. Okay, I messed that up. So basically the tag or the label, these mean the same thing. I think they call it the tag in the spec. The tag is basically saying, what is the post category? So in our case, for that one example, we saw it was euchre. The content is going to be the words in it. So it's like, what's the up card for this post? And we want to take that information and build a classifier with it. So the first file is going to contain content and a tag. And what we want to do here is we want to read that information into our structures, our data structures, we'll talk about in a couple of seconds. And we want to store that information so that when we see a new post, which is not given a label, we can go ahead and reach into our, they call it the bag of words model. I think it's a good analogy. We basically reach into our data structures and we see, okay, I see the word euchre. How often does that occur in this label? And let's say we're testing it for euchre. We're going to ask the question, how many times does the word card appear in the euchre classifier? And we've already stored all that information into our data structure. And that's the entire goal of this project. So there's mainly two phases in this. And basically we're reading in our training posts and we're initializing our data structures. And in the second stage, we're reading in a new post without a label on it. And we're basically going ahead and we're reaching into our bag of words and saying, okay, I'm going to read this post word by word. and I see that this word occurs, how likely is it that occurs in this post or this post? And by the end of that, we'll find like, okay, it's most likely to occur in this kind of post, and then we can make a prediction based on that. So that's our ultimate goal here. It's probably a lot to take in. We'll go ahead and break it down into small components so it makes more sense. So before we get started, I want to talk about maps, sets, and CSV files. These are all pretty important to P5, the driver at least. So remember what a map does. A map is sort of a binary search tree, but it has this unique property where it's going to map a unique key to a value. So have you guys talked about pairs in class yet? STD pair?
Got briefly mentioned today.
Okay, awesome. So the way a pair works is it's basically two numbers or two types that are associated together. So if I create a pair of ints, what that means is that I'll call this, we'll call it temp. I can set this equal to like 1, 1. I believe that's a syntax. What that means is that my pair is going to contain a 1 and a 1. We refer to this as the first, and we refer to this as the second. So what a map does is it's going to have a key value pair. We're going to have some type here and a type here. So let's say, for example, I wanted to go ahead and create a map that's going to map my words to their frequency. So I can do that by creating a map like this. And I can say string for a word. And I can say int for frequency. And what's going to happen here, and I'll just call this my map. The way a map works is that every key has to be unique. That means I can't have two entries that are the exact same. So if I go ahead and I create a map entry, which is, let's say, the word euchre, and I'm going to map it to a frequency, some value, let's call it 5. What this means is that the word euchre occurs 5 times in our map. So a map is basically saying, okay, I have this key right here, and associated with that key is going to be a value. Values can repeat as many times as you want. So let's say all my values happen to be 5. That is completely fine. A value doesn't have to be unique, but a key does. So in our project, with a map at least, the main purpose here is to essentially hold the unique structure we want to find. So in our case, a word, and the value can be whatever we want to be. So right here, a key must be unique again. And to access the map, let's say I want to get the frequency of some value. I can go ahead and access it by doing this. Map of key, this will give me the value associated with that key. Any questions about that?
So basically, map of key, if key was the letter, if key was the word euchre,
Yep.
Then map of key would say the number of times I have the word euchre.
Yep, exactly. You got it.
Okay.
Yep. And right here, we can see we can actually do some fun stuff with this. So let's say I have that map again of strings to integers. The string is going to be our word and the integer is going to be our frequency. And let's say I see the word euchre again. And I say, okay, this is a new post. I want to go ahead and say, I've seen the word euchre more than once. We can go ahead and just increment this counter by 1. So that's how maps work. It's basically, you can think of it like, okay, you don't know what pairs are yet. So I'll just go more in depth into what pairs are. Again, a pair is just a double, or I guess, what do they call it? It's not a tuple, but it holds 2 types. So if I have a pair of ints like this, and I say this is equal to my pair, I'll just call it that. My pair. I'm creating a pair of ints. If I want to access the first element of this pair, I would say my pair.first. And that'll give me the value of this integer right here. And if I do .second, that'll give me the second value in the pair. And maps are the exact same way. All the key is the first value in this pair. The only distinction is our map can hold multiple pairs. And also the first in our pair has to be unique. That means I can't have a map that has 2 entries for the word euchre. If I ever search for the word euchre, it has to be unique. Because think back to a binary search tree, right? if I have the value 1, and let's say I try to insert the value 1, it would make no sense to put the value 1 right here or right here. We can't have duplicates in numbers in a binary search tree. And under the hood, a map, all it really is a binary search tree of pairs. Does that concept make sense to you guys? How a BST or a map is basically a binary search tree of pairs? And we sort it based on the key values. So for example, if I had a binary search tree of integer pairs, and let's say I had the pair like 5, 3, the pair 2, 4, and the pair like 1, 5, and I said this is gonna be my root, I would have this pair 2, 4 here, I would have 5, 3 here, and 1, 5 here. So notice how this is basically a map right here. I am mapping an integer to an integer. This is the key right here, and this is its value. So once we access a key, we can get its value. Any questions about that? All right, awesome. All right, next structure is going to be a set. So a set's really cool because what this allows us to do is it basically removes duplicates from a type. So let's say, for example, I had a sentence. Let me find, do I have an example over here? Okay, I do not. So what a set does is it does not allow for repeats of a data type. So let's say, for example, I create a set called of some type and I call it name. Let's say I make a set of strings called unique words. If I go ahead and I add the word euchre to it by doing .insert euchre, this will add the word euchre to our set. So let's say our set right now only has one element, and that is the string euchre. If I go ahead and I try to insert euchre again, nothing's going to happen because I already have the word euchre in here. What happens is it'll go ahead and it will check to see is the word euchre in here, and it will see that it is because under the hood, insert uses the .find command. And all .find does is it basically returns an iterator to that word. And if the word doesn't exist, it'll return the null pointer. So what happens is if I call .insert euchre twice, it'll insert it the first time, add it to our set. The second time, if I try to insert it again, what's going to happen is that it'll go ahead and check, see that it's here and do nothing. This is really helpful because in the specifications for the project, it says we shouldn't count a word more than once per post. What that means is that if I have some post that's literally just euchre 5 times, like let's say I have a post like it's just euchre, 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 like this, and I say how many times does euchre appear in this post, we don't say 3, we actually just say 1 because we basically want to go ahead and make sure our posts have no repeats of words. And we can do that by putting every word in our post into a set, and that will automatically remove all duplicates. There are other methods, but the set one's pretty easy because set also has member functions like insert and find. So again, insert just adds something to the set, and find just says, does it exist or not? You can also traverse a set, which is very helpful for the project. The way you do that is you can call, so .begin, it's like a vector, it will return an iterator to the beginning of your set. .end will return an iterator one pass into the set. And this is sort of a traversal method right here. I recommend to use auto it because the iterator type is kind of weird. It's like std set of your type : iterator. So if you just use auto it, it should work as well. And I'm basically saying start at the beginning of my set, and while my iterator is not past the end of my set, go ahead and go forward. And this way, what you can do is just the bag of words model. Yeah, basically it is. So what I'm doing here is I'm taking all my words from a Piazza post and I'm saying remove the duplicates. You can do this by adding it to a set. So let's say all the words over here are duplicates, we get rid of them. And now what I can do is I can traverse my set of unique words and do stuff with them. And I'll get into that in a couple of seconds. But that's why sets are useful. It basically helps us remove duplicates from our data. And again, a set is just going to be of one type. You could do it of a pair. It's not useful for the project, but you can do that as well. You're probably going to want to use a set of strings here because you're working with words. Any questions about that?
So the set of strings is not a type then, or?
Set of strings, you can sort of think of it like a vector that doesn't allow for repeats. And I don't believe you can, it has random access. I could be wrong on that though. But it's basically a data structure that will contain one type and it doesn't allow for repeats.
Okay.
Yeah, if you take in 203, it's like basically the exact same thing as the set over there, where it's like if you have two types in the same set, it's not allowed. It will just like devolve into one.
Could you explain the second point under under set string unique words?
Oh yeah, the auto it right here.
Yeah.
Yeah, sure. So what I'm doing here is I've created this set right here called unique words. It's a set of strings. And I've gone ahead and I've inserted the word euchre into it. What I'm doing here after this is I'm saying auto it equals unique words dot find. So are you confused about what auto means?
Is it like a shorthand for iterator?
So the auto keyword is pretty helpful, and what it does, so okay, the return type of this is going to be like std, like set of strings iterator. It's like some long bulky word, right? And when I wrote this program, I did not like want to copy and paste that a bunch of times. What auto does is we'll say this variable called it right here, it's going to be of the type whatever this function returns. And this function returns an iterator to this element in the set. Now, as you learn about iterators, you know that there's different types of iterators, right? There's iterators in vectors, iterators in sets, iterators in maps, etc., right? And they're all of different types. So I use the word auto here because the idea here is that you can obviously use the right type, which is going to be, I think it's set string. It's like this, colon, iterator, I think is what it is. So this right here is what auto is. What I'm doing though is I'm not going to say that. I'm just going to say auto because honestly, it's just easier. It's a bit slower in terms of processing, but doesn't make a big deal in 280 because you guys aren't timed on how fast your program runs. So what this is doing basically is it's saying it is going to be the type of whatever this function returns. And this function returns an iterator to that word if it exists. And if the word doesn't exist, it will just return null pointer. Does that make sense?
Right. Yeah.
All right. Yeah. Go ahead.
Unique words dot find. The way the find is defined for sets that returns an iterator.
Yep. Exactly.
Okay.
It'll return an iterator to that value in the set, and if it doesn't exist, it'll return null pointer. So if I went ahead and I said auto it equals unique words dot find, and I did like, I don't know, like P4, it would return the null pointer. And this is helpful because when you use your calculations, someone's unmuted. Yeah, whenever you're doing your calculations on this project, what's going to happen is you're going to be analyzing words. And you want to figure out, okay, I'm looking at this new word before. Let's say I'm looking at the word set. And I want to say, does the word set occur in this like string of words? And then you can put everything into a set, and you can go ahead and figure out, is this word in that set? And if it is, you know it is, you can do calculations based on that. If it isn't, then you know to do some other stuff, is the idea.
And to reference that word, if it's found, would I dereference the
iterator?
Yeah.
Yep, exactly, you would.
Okay.
Or there are some functions you can implement that take in iterators. It honestly depends on how you want to implement it. So there's multiple implementation methods. Typically, you wouldn't use .find. What you could use is, I'll talk about in a little bit, auto for loops, or you could honestly just traverse your set like this. There's multiple methods to do it. I guess the point I'm trying to explain here is that you can use .find to see if something exists in a set or not.
Okay.
All right, awesome. Any other questions about sets? And again, I'll show like applications of these in a couple of seconds. I just want to make sure we're all on the same page and like what these data structures mean and stuff. All right, the last thing is a CSV file. So I think you guys worked with CSV files in the first project, so this should not be a new concept, but I took the class, I kind of forgot what they were. So quick refresher on that. A CSV file, it's called comma separated value file. If you guys have used Google Sheets before, it's sort of like that. The way it works is that we have rows and columns. So let's say I have a very simple CSV sheet. Everything in our first row is going to be the variables that we're concerned about. So let's say I have my first row right here, and I have stuff like content, and then I have tag. Sorry about that. My microphone muted. So we have content and tag. What's then going to happen is our second row onward is going to be data entries. So let's say the content's going to be some post, and then the tag could be something like euchre. And then our third post is going to be another entry that could be some other post, and then its tag could be, I don't know, like P4 or something. So you see how our first row is dedicated towards these words, content and tag? This is pretty nice because what we can do with these is we can actually access the content and the tag of a given post based on what line we're reading in from. We read CSV files from top to bottom. So we start off our first line right here. We do nothing with it because, again, there's no information here. It's just like the variable headers. And then our second line right here is going to be our first post. And we can go ahead and process these posts one by one. So some quick refresher on terminology. To open our CSV stream, we want to use the CSV stream class, give it some name, and enter our file name into it. We don't read in strings, which is kind of weird. We actually read in a map like this. So we can call it a string, and we call it row value. And then to read in our CSV file, we'd go ahead and say while the name of our file. So we just say like while we can read in this map of strings to strings, we can then go ahead and process our data. And what we can do with that actually is we can go ahead. I think I have it on the next slide. Yep, right here. Perfect. So let's say I want to access the tag of a given post. Remember, when we're reading a CSV file, we start from row 1 and we work our ways down. Row 2, row 3, row 4, onward, right? So let's say I'm working with the second row. If I want to access the second row's tag column, what I would do is I'd go ahead and I'd create some variable called tag, and I'd set it equal to, again, remember row value, all this is what I'm reading in. It's a map of strings to string called row value, and I'm just reading it in. And then I can operate on it by doing this. I can go ahead and take in the tag, and that'll give me the tag of the given post. Yeah, any questions, Aryan?
Yeah, so could you go back one slide?
Yeah, sure.
So when you say CSV stream name, file name, and then you have the while loop that, so basically row value would have the post and the tag.
Yeah, so CSV files are a bit different because it is a custom class. The way it works is that I actually don't know what the underlying structure looks like, but what I do know is they detail it in the P5 spec. The way that CSV files work is that when you read it in like this, what ends up happening is you can access certain columns of the data by accessing, remember how I talked about we have the first row that contains names for the data? If you want to access that data, all you have to do is just insert the name in a string format like this, and that'll give you the value of that column.
Oh, so like this one while loop would would include all the possible content and tags from the file into row value?
Yeah, so one iteration is equal to one row, exactly. So we're not reading in the file like all in one loop. We're reading it in iteration by iteration. So let's say I go ahead and I say while name, I read in row value. I can go ahead and process for one post. And after I process for that one post, I'll go ahead and process for the next post and the next post. So this right here is just a structure. I'm basically saying this is how you initialize your CSV file to actually read in from it. Inside here, you're going to go ahead and process your data. So here you'd go ahead and I'll talk about in a couple of seconds, but basically you'd go ahead and update your maps. So you can reflect like, oh, the word the occurs this many times in this post. Therefore, I'm going to update this variable, so on and so forth.
So that's the part of processing a post.
Yeah, so you're actually going to use this structure for both processing and testing, because testing, all you're doing again is you're reading in other posts that aren't classified yet. So this format holds for both, because you're reading in two CSV files. The first file you read in is the training posts that have a known label with them, and you're basically just reading that in and storing the information. And I'll talk about that in a couple of seconds. Yeah, good questions though. And yeah, you can access any information you want. So I think in the CSV file, they specify in the, it's like post is what the, that or post or content, one of those two, is basically, it'll return a string of multiple words to the post. And then you can parse that string and like add it to a set to get unique words for the post. And then you can iterate over that set to like add them to your maps, etc. And I'll go into that right now. Okay, cool. So any questions about these like three basic structures right here before we go on to the actual project? All right, yeah, go ahead. You guys can just talk.
Yeah, so it says like, if we read in from the first row, that row has like the tag and the content name, right?
Yeah.
So how would we deal with that? Would we just skip over that one?
Yeah, I believe you can skip over it. I also could be, as I say, a great question. I don't want to say this for sure, but I think when you read in a CSV file, you don't technically read in the first row. I could be wrong on that, but I'm pretty sure you start reading at the second row. I can get back to you on that if you want after the session.
Yeah. Awesome. Thank you.
Awesome. Yeah, someone give you the wrong answer or anything. And then I think good question, Aryan.
Oh no, yeah, I'm good. Thank you.
Okay, you're good. Yep. All right, good stuff. All right, awesome. Let's go on. So there are three main things we have to do for this project. The first is make a class. I mean, that's pretty obvious. Second thing is we have to train our data. And the third thing is output predictions. So training data is what we'll talk about first. And then outputting is pretty simple once you handle step number 2. So yeah, it's kind of like the basic 3 steps here. Honestly, this project isn't that like time intensive. It's about 300-ish lines in length. So it's not like a huge eyesore to take care of. So first thing to talk about here is like, what do we actually need to take care of? Like, what information do we need from our training posts? Like, what do we need to keep? So there are 3 things we have to keep track of. So I'll go ahead and give an example of a post. I'll say like, why is euchre so hard? That's gonna be our post. And in our training set, we're gonna get a post and a label. And our label for this is gonna be euchre. What we want to do here is whenever we're doing a training post, we want to go ahead and add this information to our data structures. So we want to keep track of 3 things here. The number of training posts with a given label. So every time I read a training post, I want to go ahead and reflect that I have seen euchre one more time. So how do we do that? Can anyone think of a way of how we can keep track of how many times euchre has occurred?
Pair you just showed us.
Sorry, what was that?
The pair you just
Yeah. So a pair is a good idea, but why could that not work in some cases? A pair, so intuitively, you're right. You want to go ahead and keep track of a pair, but there's a different structure we can use that's better than a pair.
I guess we can use like a map with string and ints.
Yep, exactly. So pair is a great idea. The reason why it couldn't be the best solution, though, is because you don't know guaranteed what your post titles are going to be. Because if you create a pair of euchre to ints, right? That's fine, right? You can go ahead and access that singular pair. If I go ahead and I give you a post tag you've never seen before, if I give you a post tag for like EECS 281, right? You never explicitly say that in your pair, so that never work. The reason why a map is so good is because you can add new entries whenever you want. So if you create a map of strings to ints, whenever you go ahead and you add something, let's say, for example, I want to reflect that I have seen euchre one more time. I'll go ahead and I'll call this structure right here map. And it's mapping strings to integers. If I wanted to reflect that I've seen euchre one more time, all I have to do is go ahead and say map of euchre plus plus. And I'll go ahead and increment how many times I've seen euchre by 1. Now, a common like misconception here is, okay, what if Euchre isn't inside our map yet? Well, maps are pretty cool because if Euchre does not exist in our map, if I go ahead and I access it and it doesn't exist, and then I perform this plus plus operation, it'll go ahead and it'll create a Euchre inside of our map and set to 0. And then if I do plus plus, it'll set equal to 1. So this map handles initialization as well as incrementation. So that's pretty cool. So-
I had a question. I'm sorry to interrupt.
You're good. Yeah, go ahead.
Yeah, so I was just wondering about like, so you said that the message on the top is like, suppose we have like a post like, why is Euchre so hard?
Yep.
So after that we identified Euchre is the project that we're talking about, but like, how do we actually know which is the label? Like, will that be given to us? Like,
Yeah, there's a CSV column. It's called like tag, I
that's
think.
what I was thinking. Like, yeah, so it will be mentioned in the CSV column. So Euchre, and then why is Euchre so hard? All right.
Yep, exactly. You have to know that training. So yeah, this is called the supervised learning problem in machine learning. It basically is we know the answer already, right? We just want to train our classifier so it can like basically refer back to this information when we don't know the answer.
Mhm.
It's sort of like making a study guide, right? If I give you a test for 280 and I say, okay, here are the answers to it, and you study it, you know the answers, right? If I give you a new test, you're basically relying on your past knowledge. That's all machine learning is. You're relying back on old knowledge you've seen before. So for example, if I give you this post by say, okay, you don't know it's Euchre anymore, right? You're learning, your ML algorithm will go ahead and say, Euchre, I see that. That's a big word. And it will weight that so that we predict Euchre. Yep. That's a great question, though. It's a great question. Okay, let's go back to this. So yeah, the map handles initialization and also handles incrementation. So right here, we have a map of strings to integers. If I go ahead and I do map of Euchre, I'm accessing the frequency, right? And let's say Euchre didn't exist. If I go ahead and I access Euchre, it'll go ahead and it'll create Euchre inside of our map. So you don't have to worry about, okay, what if Euchre doesn't exist? Trust me, it takes care of it. So it's pretty good. This will initialize it, or if it already exists, it'll just access it. And then plus plus will add to the frequency. Is the presentation in the drive? Yep, it is. And then for typos, that's a great question. We don't in this project. So if you take EECS 445, which is the machine learning class, you do have to deal with that. But yeah, typos are fine, unfortunately. So it makes coding a lot easier though. So like even if a word's like missed, like don't worry about like what the words are, just like reading the words. Like even if they make like no sense, like if someone just types in gibberish, like it's fine. Like just process it. All right, awesome. So we keep track of that. Second thing is number of training posts. I'll go at number 3 and then I'll go 2 because 2 is a bit complicated. So 3, number of training posts with a given word. Can anyone think of a structure for this? Anyone have any ideas?
I think it should be a set because we just want every single word. So I mean,
Yeah, so that's a great point, but look at this. We're looking for the number of training posts with a given word. So we're asking ourselves out of our number of training posts, how many times does this word occur in our data set? So
pair again.
a map again?
Pair.
Pair. So I think, so yeah, pair is a great idea again, but map sort of contains multiple pairs, right? And we don't know how many words are going to be our data set. So a map is essentially just holding a bunch of pairs. So I think you have the right idea. Yeah, so it's going to be a map. Again, a pair is just going to be a like 1, and a map's going to hold a bunch of pairs. Does that make sense?
Yeah.
Okay. So yeah, a map will hold multiple pairs. So right here, notice how 1 and 3 are pretty similar. Number 1 is asking us, okay, how many training posts contain this label? Number 3 is asking us, how many training posts contain this word? So again, if we just map a string to an int, all we're doing again, let's say I see the word card. I can go ahead and reflect that by saying map of card, and I can increment that to say I've seen the word card more than once. The big thing in number 3, though, is remember this. For a given post, we are only concerned with one word, right? We do not want repeats. So again, let's say I have the post, Euchre is hard. I don't like Euchre. What we should do in this case, whenever we get this post, there are multiple approaches to this. What I did, and I think a lot of people do this as well, is go ahead and add every word to a set. So remember back to what a set does. A set will remove all the repeats and only allow for one of each type. So we see we have the word euchre here twice. Whenever we add this to a set, we're getting rid of one of these copies of euchre. So whenever you go ahead and you process your data for this right here, number of training posts with a given word, you want to make sure you're getting rid of the repeats, or else your data is going to be a bit inflated. All right, so number 2 is a bit more complicated. So we're asking ourselves a question, number of training posts with a given label that contain a given word. So that's a lot to take in. So what does that mean exactly? So what I'm saying here is basically, I'll say the label is going to be euchre. Label equals euchre. So given that the label is euchre, I want to know how many times does the word card appear? Does that idea make sense to you guys? What I'm asking here?
Yeah, like a subset, sort of.
Yeah, exactly. That's a great way to think about it. So I think a subset is the best way to think about it, because what this means is that we have to have a map for each type of label, right? So we'd have a map that'll map, let's say I'll have a map for euchre, and this map for euchre is going to have every word in the euchre post to its frequency. So word to frequency. So in this case, we'd have a map of strings to integers. And so I'd have this individualized set map for euchre. Now, the issue of this, it works, but again, the issue is that we can't explicitly create a map for every data type or every single label we encounter, right? Because we might encounter some labels we haven't seen before, and that could be an issue down the road. So what we do here might seem a bit weird, is we have to create a map of a map, and I'll explain what this means in a couple of seconds. We're going to create a map of strings to a map, let me get a different color out, of string ints. So what's happening here is this string right here is going to be our label. So this would be the map, and it'll be for euchre. What I'm saying here, remember that this is going to be a key. And all the keys have to be unique, which is perfect, right? Because I'm asking ourselves the question, we are given a label, and we want to figure out how many times does that word occur given that label. So if I go ahead and I access this map, and I give it the keyword euchre, I don't actually get a value. Instead, I'm getting a map of words to frequencies.
And the words will be all the words that are related to euchre.
Yep, exactly. So every word we've encountered in our euchre post, right? We read in the post for euchre and we see, why is euchre so hard? We want to go ahead and we want to add those words to this data structure right here. Because this tells us, okay, for the label euchre, what are the words associated with that post? So let's say I want to figure out how many times is the word card associated with euchre. What I would do is right here, I'm accessing the euchre map, right? I am right now accessing this map right here. Whenever I say map of euchre, I'm accessing this map of word frequency pairs. To go ahead and access the frequency of a word, all I have to do is add in this right here. I'll say card. And this gives me the frequency of how many times does the word card appear in the label euchre. Does that concept make sense to you guys? What's happening here?
Yeah, it's like a double index kind of thing.
Yeah, exactly. So visually what's happening, by the way, is let's say I have a binary search tree. You can sort of think of it as like, okay, let's say I have 3 posts. I have euchre, P2, and P4. I said I want to find my map of euchre, right? When I do that, I'm going into my binary search tree, and I'm going to find the value associated with it. the value isn't going to be integer, it's going to be a map, right? So if I'm saying I want to find the map of euchre, it's going to return to me a map, right? And then I can go over here and say, okay, this is going to be the map of euchre. And in that map of euchre, I will have the word frequency pairs. So all of these nodes right here, all of these labels are all their own map within themselves. And we're just choosing what map we want to access. Any questions about that?
So when we say the number of training posts with
Mhm.
like these 3 conditions, then
Yeah.
does that mean that does the training posts mean the content?
So yeah, training post. So every training post, right? It's going to be a line in it's going to be a row in a CSV file, right? So the way it should work essentially is number of training posts. Let's go back to this real quick. Whenever you read in a row from a CSV file, you can basically say like number of trainings, so like num posts plus plus. So each post is going to be one line on a CSV file. And that's reflected by just having a tag or the label and then some content or the post. So I hope you guys can see the full picture now. What we're doing is for every row in a CSV file, we want to go ahead and look at the tag, look at the content. We want to go ahead and process this information right here. We want to get number of training posts with the label. So we want to figure out how common is this label? Like how often do we see the label euchre? Right here, we see, okay, given a label, how common is this word? That's number 2. And number 3 is, okay, how common is this word to begin with?
For number 3 is when they say given a word, is that a word in the content?
Yeah, so the content, again, I'll have like a bunch of words. I have like 5 words here, right? What you want to do is you want to go ahead and remove duplicates first. So you want to go ahead and enter this all into a set. And let's say if we enter into a set and there was a repeat, what happens is that word gets deleted. And then we can iterate through our set. And we can process word at a time. So we can have an iterator pointing to our first word in the set. And then we go ahead and calculate these 3 probabilities. Well, I guess you wouldn't do this one because it's a word. So you'd calculate this one only once per set or per training set, right? After that, you want to go ahead and calculate these 2 things right here, given that word. And after you do that, you want to iterate to the next word in your set, and so on and so forth until you reach the end. After you reach the end, you're basically done with that row, and you can then move on.
But for number 3, why would we need to remove the duplicates? Because don't we need to find the word, the given word in the number of posts?
Yeah, it's a great question. So you can actually, so the reason why you move the duplicate is because it's asking us for a training post. It's basically a yes or no question. If I give you a post that says it's literally just euchre, and I say, does the word card exist in this? You would say no. So you wouldn't go ahead and increment this. If I said, does the word euchre exist in that post? You would say yes. If the post was euchre, like this, and I asked you, does the word euchre appear? You would say yes. Notice how the number of this is 1 training post, right? So this word euchre being here twice doesn't actually impact our answer. What it does impact is this probability right here. Number of training posts given a word. You don't want double count here. And also, the reason why removing this duplicate is important is because if you were to count this twice, you would say 2 training posts contain this word euchre, which is wrong because we were only analyzing 1 post right here.
I had one question. So since the second one depends on basically the first and the third one, so basically do we calculate 1 and 3 first and then we like calculate the second one?
So that's a great question. What you can do, honestly, is first go ahead and calculate 1, right? 1's pretty easy to calculate because you only do it once. After that, what I would recommend doing is adding all your words to a set. So I'll go ahead and create this diagram. I'll say this is my set. and then you want to iterate through it. That'll be another for loop, right?
Mhm.
After that, what you can do is go ahead and update these like in order. It doesn't actually matter, right? Because all I'm saying here is reflect this word existing in this map and in this map, right? Notice how this one is only reliant on this word label, but we already know that, right? Because we already found that out. Like we can just read that whenever we want. So 2 and 3, do in either order you want. You can handle in one loop as well because you're working on the same set of words.
Mhm. All right, I get it.
Yeah, of
Thanks.
course. Good stuff. Good stuff. All right. So any other questions about this?
Yes. I'm just trying to like understand what we're supposed to be doing, and basically we're given a CSV file, we read it in.
Yep.
And then you read in each row, and then you put the tag into a map.
Yep, exactly. So you put the tag, okay, let me find, I have an example somewhere. Okay, right here. So that's a good example. Let's say I read in this row from our CSV file. I have the label euchre, and this is the content. How do we use the right value in euchre? Euchre is pretty hard. So what happens here is you first read in a CSV file, right? You want to go ahead and reflect the fact that this post is a euchre. To do that, all you would do is you'd access your map of strings to integers, where the string is going to be a label and the integer is going to be the frequency. And you go ahead and say, okay, I'm going to reflect the fact that I've seen this post euchre. So I'd go ahead and say euchre, and I'd say plus plus. This is basically us just saying, I have seen the post euchre, and I'm going to say this occurs in one more training post. So have I lost you yet, or does that make sense?
Yeah. So if we wouldn't know if it was euchre, right? That would just be like a string variable that we could set equal to the map's string.
Yeah, exactly. So
Excellent.
you read it in the CSV file, right? And there's going to be this column called, like, I think it's called tag in the CSV file. You would just read that in, and it would, like, in this case, it would return euchre. You can then insert that string into your map and say plus plus, and that'll increment euchre in your map.
Right.
So you know it's euchre because you're training it. Like, you know that this post is euchre, so you can go ahead and reflect that.
Oh, okay.
Yeah. And then the exact same process works with the words. We have like this giant sentence, we add it to a set, remove duplicates, and we then, I think I have it right here, yep. So we have like all these words right here. We then go ahead and we access each word individually. And I do the exact same process. I say, okay, I have this word. I'm going to go ahead and update it in my map to show that this word has occurred one more time per post. And then the second bullet point over here was, okay, I'm given this label. How many times does the word occur? And then we can reflect that change in that map as well. So I guess visually what's happening is we have all these words. So I'd first go ahead and I'd update euchre to exist one more time by incrementing that map for labels. Next thing I would do is I'd go ahead and add all these words to a set. So I'd remove like the word euchre because it occurs twice. And then I'd go ahead and iterate over the set. So I'd start with the word how. I'd go ahead and update my map of string ints. This is my map basically saying how many times does this word occur, or like per training post, like how many times the map, or how do I phrase this? It's out of our training posts, how many times does this word occur? So let's say I have like 10 training posts. So I have 10 rows in my CSV file. What I want to do here is reflect that this word how occurs in one more of them. So to do that, I would go ahead and access this map, and I would pass in the word how, and I would update its frequency. After that, what I would do is I'd go ahead and reflect the fact that euchre exists in my map as well, and also has the word how related to it. And to do that, I again have that 2D map. So I'd go ahead and I'd say my map containing euchre with the word how, I'm going to update like this. So I guess I can draw on all three of these. So it makes more sense when I'm updating at each step. So I'm updating my label map to show that euchre exists, that this post is euchre, like this. I'm also showing that the word how exists in this post by incrementing it by 1. And then I'm saying, okay, the word how and euchre are associated because how is a word under the post label euchre. And I go ahead and update that by saying map of euchre of how plus plus. And then you can go ahead and create these 3 maps in your class.
Okay, so we'd have 3 maps.
Yep, exactly.
And then one of the maps would be a map from a string to a map, basically, right?
Yeah, this would be the map. This right here would be a map of strings to a map of string ints.
Okay. And then, so for like those 3 things that we talked about, those would just be ints that we would also store in the class, correct?
So you wouldn't like, okay, so that's a great question. You're not really storing those in the class because you create this map, right? The ints are just stored inside of your structure, right? You don't have to explicitly state those. Yeah, they're just in your structure.
Okay.
Yeah. So like these 3 maps will hold all our information, right? This is like pretty
Yes.
low in terms of like how many variables you actually need because like this map will hold everything. Like this singular map will tell us how many times any label occurs in our training set. This one right here tells us how many times any word occurs, right? Let's say I enter a word that doesn't exist, right? It'll just return 0, which is perfect.
Okay.
Same thing for this. So we really only need these 3 data structures to actually interact with stuff. The set I mentioned earlier is just good for like processing the data, but like, again, there's other ways around it, or you can just create it temporarily. Yeah, go ahead, Arian.
So just so that I get this straight, so the first line there, that's calculating the number of times we have a post label named euchre
Yep.
in the entire training data.
Mhm.
And the second line is calculating the number of times I have the word how in all the contents for all my training posts.
Yep.
Right. So, but since you to implement the second line, you used a set that removed all the duplicates for one training post.
Yep.
So wouldn't you have a lower estimate because of that?
Yeah, it's a great point. So what's happening here is we're only concerned with, okay, how many times does the word how occur? Like how many training posts does the word how occur in is the proper way to ask the question. So I might have misphrased it before, but I'm asking us like number of training posts that contain the word how. The number of training posts that have the word how. Again, we don't care that the word how occurs twice. We're concerned with is the word how occur at all. And again, you can probably argue that like one, it'd be beneficial to know if the word occurs more than once because like that could indicate a correlation. Yeah, it could, but like we're not doing that, unfortunately. So that's good thinking, but we don't do that. We're only concerned with how many times does the word occur, like how many training posts does the word occur in.
This might sound a little like a simple question, but
You're good.
Have it, it's map brackets quotes how plus plus. So we won't know exactly what the word is like in those quotes.
Yeah.
So should we be passing in, for example, just like a string? So for example, like a string named value. So take away the quotes and do map without the quotes value plus plus.
Yeah, that works. That's perfectly fine.
Okay.
So what you can do, let me go back. Let me find it real quick. Where do I have the set? Okay, right here. So I have the set, right? So notice right here how I'm accessing every word individually for a post. I have my iterator right here. All I can do basically is go ahead and say like, oh, like value, like string value equals like it dereferenced. And since our set contains strings, if I go ahead and dereference this, that'll go ahead and give me the value of the string. So that'll give me the word how. And then if I increment my iterator, it'll go to the next word in our post right here, right? I'd then go to the word do, and I'd do the exact same thing, right? I'd go ahead and I'd access the word do in our iterator. I would set value equal to it, and I'd go ahead and update these two maps. I'd go ahead and put in the value, which is now do, and then I'd go ahead and put in the value do for this. Euchre wouldn't change, obviously, because it's the same post, but the idea still holds.
Right. So for example, it would be map bracket value. So after the string value is equal to plus plus it.
Yep.
Map value plus plus, because value holds the how. And then after that, you do map value 1, I guess, for the label.
So label, again, we can go ahead and just say like, so I think I have it like way back here. Sorry, I'll keep switching back between these things. So right here, right? You can maybe see it. I have string tag equals row value tag.
Right.
That gives us our label, right?
Okay.
That's gonna be a string. So all I'd do is I'd go ahead, where was it? Okay. I'd go ahead and say map of tag.
Map of tag value.
Yep. Exactly. You got it.
Okay. Excellent. Perfect. Thank you.
Yeah, of course. And that's it. So that is essentially it for processing. So just a quick overview of what we did. We basically went in and we read we first created a set of our words, removed duplicates, and we then went ahead and processed our data by adding them to our respective maps that we just drew over here. So any questions about how I got like those maps and like what they mean and stuff?
I had a question on, so those 3 steps, where do you perform those 3 steps?
Oh, where do I do those? In the while loop, right? So right here, I'm just reading in the CSV file. Let me go back to this. Yeah, like right here.
Mhm.
I'm reading in each row. So I'd go ahead and I'd calculate the first thing, second thing, and third thing. One other thing you might want to calculate is number of training posts, right? We know that we're reading in one post at a time. So you can literally just have a counter up here. It's like training post plus plus. Because we need that later on.
I see. So the row value here is one training post.
Mm-hmm. Yeah, exactly. All right, so I'm going to go ahead and re-explain this 2D map real quick because I had a question about it. So just to reiterate what map of string of a map means. So the entire purpose of this basically is we want to keep track of how many times does a word occur given a Piazza post label. So what we have here is a map of a string. Its value is going to be a map of a string integer. So what does this mean? This means that I am mapping a label. This will be a word, and this will be the frequency. Whenever I want to update the fact that a word has been found given a label, what I would do is go ahead and say this map, given a label, I'd enter in the label, and notice what happens. I am now accessing this unique map of that label. And this map, again, is just going to be a string to integer. So it's going to be a word frequency pair. If I want to go ahead and update the fact that I've seen this word one more time, I would go ahead and pass that word. We'll call it value. And I would say plus plus. So what's happening here, again, is that every string in this 2D map is going to have its own unique map. And that map is going to contain the word frequency pair. So we're basically just, you can think of it like we have multiple maps. We have one map for each label. And that map for each label is going to contain a word frequency pair. Does that answer your question? Why double map? Oh, that's a great question. So double map because we need to keep track of the word frequency pair for a given label, right? So let's say I want to find how many times the word euchre occur in the post P4. I mean, the answer should be 0, right? But that's a different question than asking how many times the word euchre occur in general, right? Because the word euchre might occur like 11 times in general but all 11 of those come from euchre posts, right? If I want to figure out, I see the word euchre, how likely is it that it comes from this tag P4? The answer would be 0, because what would happen is I would access this map with label P4, and then enter in the value euchre. And that would tell us 0. Which makes sense, right? The word euchre should never be referenced in like a P4 Piazza post, maybe a misclick or something like that. I don't know. But the entire point of keeping track of this information is because we want to, when we're testing our data, when we're making predictions, we're going to read in word by word, and we want to see, okay, I'm seeing this new word, right? I'm seeing the word euchre. I want to see, would euchre belong to the tag euchre or project 4? And we can go ahead and then enter in that word in our testing set or our prediction set and figure out what's more likely, that the word euchre appears in the label euchre, or that the word euchre occurs in label P4. So double map is to build connection between them for machine learning. Yeah, exactly. You want connection established. All right. Any other questions about the processing stuff? Because honestly, the rest of it's pretty simple after this. So just make sure we get a good understanding of this.
The initial while loop you had, the condition for that, so having the name arrow row value, that by itself take care of how a single training post is being added to our map.
Yeah, so what's happening here is we're reading in one row at a time for our CSV file. And once we get to the end of our CSV file, we'll stop reading in and the while loop will terminate.
Okay, so for each iteration, the row value would have a unique training post.
Yep, exactly. So after so let's say I go ahead and I process for the first row. It'll go ahead and it'll do everything in here, and it will then end the while loop. It'll then go back to this, get in the next row value from our CSV file, and we'll then process the second post and the third, and so on and so forth.
I see. Right. Yeah, that makes sense.
All right, awesome.
But just for clarification, all those times you wrote like map brackets, that would just be the name of whatever we named our maps, right?
Yeah, exactly.
Okay.
Yeah.
Thank you.
So like I called mine like row value here. You can call it like whatever you want, but yeah, it would be the name of it. All right, so we've calculated all these numbers, right? So how do we actually access these and use these for like predicting and stuff? So in this spec, they give these equations right here. So we've already calculated all 3 of these. So like right here, this is number 1. We calculated this. Number 2, we calculated this. And number 3. Notice all we're doing here is taking the natural log of the value we calculated over number of training posts. Or in this case, we're using the double map. So we already have all of this information stored, right? The question is, how do we access it? So when we predict a post, we'll go ahead and move on to predicting now. Let me go ahead and, where is that? Okay, predicting. Let's say I have this post right here. I have no label for it. Well, technically we do have a label. We use that for accuracy, but we're not allowed to like use it. So all we're given here is this post. What is a null pointer in a linked list? And like, is it like 0 for linked list? Question mark, this post right here, right? Our job is to figure out, okay, what is the most likely tag for this? And how do we calculate this? What we do is we go through and we process every single word for a given tag or given label, whatever you want to call it. We know our unique labels, but how do we actually know that? So let's say I've gone ahead, I've done the processing step, right? I have these maps, I have all these, let me go back to this, sorry. I have all this information, and now it's time to actually utilize it. I'll go ahead and draw our maps up real quick, just remember we have. We have a map of strings to integers. I will call this label frequency. We have a map of string of map of string int. And this will be our label word frequency. And then I finally have a map of string ints. And we'll call this our word frequency. So a couple of things we're actually get started in this. Our goal here should be, we want to go ahead and it's called calculating the log likelihood. And all we're doing here is we're testing all of these words essentially on this right here. We're saying, given the word what, how likely is it that it occurs in some post string? That's our job here. There's also some other nuanced calculations you have to do. It's detailed in the spec. I'll cover that in a couple of seconds. But we basically want to go ahead and use these three maps to calculate how likely this word is to be inside of a given label or given post. We want to go ahead and find the aggregate of that for every word, and then based off of that, make a prediction. So our first step should be, okay, how do we go about testing these words on a label? Like, what even is our labels here? Well, the fun thing about this actually is we have maps, right? Maps are pretty cool. So right here we have a label frequency, and we know this will map some label to a frequency. If I wanted to go ahead and figure out, okay, how many labels do I have and what are their names? We can do that. What we can do is like a for loop. And I can say for auto label colon label frequency. What this does is it'll set label equal to one of the labels in our label map. And it will go through and get us every single label from label map. So let's say, for example, this is right now setting it the label equal to euchre. I have just accessed a label from my label frequency map, and we'll call this euchre for now, right? I can then use that information to go ahead and read in this post. What is the null pointer and linked list? Like all this stuff right here, right? I can then go ahead and calculate the probability of the word what occurring given this label. So notice here, all I'm doing is I'm calculating this, the log probability, this formula over here. Where was it? I'm calculating, where is it? Yeah, right here. Number of training posts with label X that contain word W divided by this number right here. We already have the information. All we're doing is testing it on the label euchre. And right here, I've detailed out exactly what's happening. So right here, we have like label map holds the labels frequencies. I'm going to go ahead and set our auto iterator equal to our beginning of our label map. After that, I go ahead and I'm saying, while I'm not pointing past the end, I'm going to go ahead and update our data with the label. And right here, all I'm doing here is looking through the contents of the post I'm reading in, and I am going to calculate the log score based on those words. So notice how this is almost the exact same as the first the processing part, right? Instead, all we're doing here is we're testing out 5 or like however many. Let's say our label set is like 5, right? We're testing out however many labels we have right here in our label map on this sentence on the post right here. So for example, let's say I go back to this example right here. And I have in my label map, remember it's a binary search tree under the hood, I have P3, P2, and P5. I only have 3 labels. What I'm doing here is I'm going to go ahead and calculate what is the probability that, let's say I have some map, and I'm going to test out P2 on every word in this post. So go ahead and find out what is. and I would use that formula from the previous slide, and I'd get some number. I'd go ahead and add those up for every word in the post. And my goal here is to find the smallest one. So after I go ahead and compute the log probability of this existing, after that, I can go ahead and compare it to the best score I've gotten from these 3 posts. After I do that, I'd go ahead and say, okay, I've done P2. Let's go ahead and calculate this entire sentence for P3. I'd iterate through that, go ahead and calculate my log score for this sentence or this post right here. After that, I'd go ahead and compare it to the previous one. If the score was closer to 0, that means it is more likely. So I'd go ahead and I would have it, this one be the likely post. I'd say P3 is the most likely post because it has the smallest log score. After that, I'd go ahead and compute P4. I'd go ahead and test out probability of what occurring given P4, then is, then the, I'd add those all together, I'd find a number. And after that, I'd go ahead and compare it to the previous. And I'd say, which one is more likely, P4 occurring or P3? Once I'm done iterating through that, I'll have an answer. And then I can make a prediction. And based off the lowest log score I get from these 3 labels right here, I can go ahead and say, I think the post is going to be P2 with a log score of this. After that, what you have to do is in the Csv file, they actually give you the answer, and you can go ahead and compare the 2 and see if you were right or not. If you were right, just add 1 to your accuracy. If you were wrong, then you just don't do anything. And at the end, you're going to basically output your accuracy rating and your overall like percentage of posts you got right. So that's probably a lot to take in. So I'm happy to answer questions about it, but I think this structure right here is pretty helpful. So yeah, any questions about predicting?
So for predicting, they gave us, or I guess we would have a post that's without a label, right?
Yeah, so you're basically given a, so remember back over here, we were given the post label and the content. Right here in predict, we're actually given both of these, right? What we can't do though is just say, oh, it's gonna be a euchre, right? What we want to do is use the information we learned in our training set and go ahead and calculate the predicted label using this. After we compute the calculated label, let's say I calculate this is going to be euchre. I would then compare this to the post label given to us, right? So in the predicting set, they actually do give you a post label, right? They say don't obviously use it because you're graded on like if your thing like works like theirs does. So like there's no point in gaming the system because they actually won't help you at all. You basically want to go ahead and just calculate the predicted post, compare it to the actual post label, and then if it's right, you can say like correct plus plus or something like that, or correct is like the number of posts you got right.
I had one question. So do we actually end up using our implementation of the binary search tree in the main function?
That's a great question. You actually don't. You want to go ahead and use std map. The reason it's a great question. The reason why is because our binary search tree, while it does work, it is kind of inefficient. So I think I talked about this last time, but it's called a stick, right? Let's say I keep on adding values to a binary search tree and it looks like this. This is pretty bad, obviously, because if I want to search it, it takes O of n time and not O of n log n time. Whereas the standard template library, their version is called an AVL tree, which will basically balance itself out. So it's O of log n time. So go ahead and use std map instead of binary search tree.
All right, thanks.
Yeah, of course.
Also, I had a few questions about maps. So, I mean,
Yeah, once we're done with the main part, I can go over that.
Sure, thanks.
I had a question about the calculating the probabilities.
Yeah, sure.
So we're supposed to calculate those numbers each time we run through the loop, right? You know what I mean?
Yeah, exactly.
So then if because you said have like a counter variable for the total number. then wouldn't the probabilities be different based on how many you've already read in?
So you aren't updating anything in your maps based on your predicting set, right? All you're doing is accessing information you already calculated. You're not in in predicting, you aren't going to go ahead and ever use like ++ on a map, right?
Okay.
You never actually want to go ahead and update a map. You just want to use the information you already have.
So do we only do those calculations in predicting, not in training?
Yeah, you only do the calculations in predicting. Training, there's no math involved. All you're doing is incrementing stuff.
Okay.
So when I had those calculations pulled up, it might have been a bit confusing. So I'll go clarify that real quick. I have those 3 calculations. You only use these in predicting. But you go ahead and you gather this information, right? You gather these maps and processing. So processing basically is getting all this information, right? But then you want to utilize information in predicting.
I see. Okay, thank you.
Yeah, of course.
So for the probability scores, like the log values that we get, do we store those in a vector in a map as well?
You actually would not, because remember, you're only calculating it. So let's say I'm reading a post like this, right? And again, let's say I have 3 labels. I have P2, P3, and P4.
All right.
P2, P3, and P4. What I would do here is I would go ahead and I would look at those 3 labels, right? Using the auto for loop.
Mhm.
And I would calculate the log probability of all of these words given P2, right?
Yeah.
I would then go ahead and say, okay, if this is bigger, or this is my best log score so far, set my predicted label to be P2, right?
So it's like it just keeps incrementing if we get a better one, or it remains the
Yep.
same. Next one is not as good.
Exactly. It's sort of like maximum in the vector we did in P1, where it's like, is this better? Okay, it is. Cool. It's my new best.
Yeah, that makes sense then. Yeah.
Yeah, good stuff.
I'm still kind of confused as to how you get the probabilities for like the word when you are given like the content for that post.
Yeah, sure. So let's go back to the calculations real quick. So right here, we're asking number of training posts. By the way, there are other calculations besides this one you do in the predicting set. You also do these 2. And I believe there's a certain way you calculate them. You use these formulas, obviously, but there might be a different like weight placed on them. I could be wrong. I'd read the spec for it, but this is like the general idea, right? So don't take like these these formulas are right? But like I didn't show the actual equation for it because it's like some obscenely long thing where you add like, I think it's like 4 or 5 values together. But basically what we want to do is, given a training post, you want to first calculate this. This is pretty easy because you already have this information. And then I talked about like accessing each word in the training post. That's where you calculate these 2 things, like the number of training posts with word W. That one's pretty basic. You access your map of strings to integers, your word frequency pair. And this one right here is just accessing your map of a map. Sorry, what was your question again?
Yeah. So once or I guess like after finding the probabilities for each word in our content, how are we going from there? How are we going to like predict the label for that post?
How are we going to predict the label when we read it in the? So you're talking about like predicting, right?
Yeah.
So like once we read in all this stuff, how do we actually predict the label?
Yeah.
Oh yeah, so that's a great question. Again, we have labels. Let's say again, this example, our label map has 3 labels: P2, P3, and P4. What we would do is we'd calculate the log score of P2, right? And to do that, we'd first have to figure out, okay, what's the log likelihood that P2 is a label? We go ahead and calculate that. After we do that, we want to go ahead and calculate the probability of what given P2 and the probability of what in general, like how many times does the word what occur in all of our posts. After that, we'll get some value. It'll be negative because obviously it's like logs of fractions, so it'll be some negative value. And we want to go ahead and figure out which value is the least negative. And once we have that, that means it's going to be the most likely post. And we'll go ahead and calculate that for P2. We'll figure out, is P2 better than our current best? And since it's the first thing we're calculating, we'll say it is. We'll then go ahead and do the exact same process for P3. If P3 is greater than P2, meaning it has a lower log score, we'll go ahead and say P3 is our new predicted label. And then same thing with P4. Once we're done iterating through all our labels, we'll go ahead and output our current best. Like the post with the lowest log score. And it's sort of like keeping track of a maximum, right? So like we'll compare the two values and figure out which one is the best so far. And when I say best, I mean it has like the log score closest to 0.
I see. So I would still be doing like a greater than the previous thing, right?
Mm-hmm. Exactly. You're just comparing the newly calculated thing, the newly calculated log score for a given post to the current best one. Here's a good example for it, right? I give you this vector 3, 5, 2, 7, and 4. And I say, okay, let's go ahead and figure out what's the biggest. I'll look at 3 first, and I'll say 3 is my first element, so I'll say it's the greatest. I'll compare it to 5. 5 is bigger than 3, so 5 is my new biggest. I'll compare it to 2. 2 is less than 5, so I don't update 5 at all. I compare 5 to 7. 7 is bigger than 5, I'll say 7 is my greatest. And then I have 4. 4 is less than 7, so I say 7 is the greatest. After that, I'm done iterating through the vector, and I'm left with a maximum of 7. It's the exact same process for calculating the log score, right? All I'm doing here, this is a very basic example, right? Because it's like the biggest value in a vector, and this is like machine learning stuff, but the same intuition still holds. We're going through and calculating the log score for P2. I go ahead and set that as my current best because it's the first one in my, it's the first label I consider. After that, I go ahead and calculate the log score for P3. And I say, is that better than P2? If it's better than P2, that means P3 is my current best, meaning it's my predicted.
Mm-hmm.
And then I'll compare P4 to P3 or P4 to my current best. And I'll say, is P4 better than my current best? And if it is, then P4 will be my predicted label. And after that, I have no more labels to look at, so my while loop terminates, and then I'm left with a prediction and a log score. Does that make more sense?
Yeah.
All right, good stuff.
Thank you.
Mm-hmm. Any other questions about the driver?
I have a question about when we're reading in the content of the post of what it wants, I guess, not the label. And we're going through that long string. Are we supposed to use a string stream to iterate through each individual word?
Yeah, you can do that. That works.
Okay, cool.
Yeah, you can do a string. Yeah, go ahead, sorry.
I was just thinking which way would be what way would be better, because all I could think of was string stream. I was wondering if there was a different way to do that.
That's a great way to do it. So what I did is that I created a string object, and then I went ahead and parsed all of the strings into a set to get unique copies of them. But yeah, string would also work too. I think that's the best way to actually extract all of the words from the post.
Okay, cool. Thank you.
Yeah, of course. And yeah, just to clarify for those people that didn't know what she was talking about. So whenever we read in a post, right, we're not given each word. We're actually given this entire block as one string. So we have to go ahead and we have to, transfer. We have to extract all of these strings from this giant string. So if we use a stream string, that will basically allow us to access every word in the string. And then we can add all those strings to our set, and then that will basically give us the unique number of words for the post. But yeah, it's a great question though. All right, anyone else have questions about driver? If not, we can go ahead and talk about map real quick. So I didn't prepare any like actual, what is it called? Let me stop sharing my screen. So I can go ahead. I didn't make anything, unfortunately, for it because I kind of forgot it existed, to be honest. So what I could do, I'll leave it up to you guys, honestly. I can cover map right now without any like material. So it wouldn't be like the best, obviously, or I could record something and post it like later and take a 30-minute tutorial on how to do it. I can answer questions now though, because I don't think it's that long, so it shouldn't be like the worst thing. Let me go ahead and just get a blank canvas up so I can draw some stuff out for you guys.
Yeah, I had a few questions about it.
Yeah, sure. Let me go ahead and get my pen out real quick and start sharing. Okay. Recording would be helpful. Yeah, I can do that too. So I'll go ahead and just pause the recording then, because this probably won't be the best information to watch. So if you're watching the recording, thanks for coming. And I'll post the recording for maps sometime later this week. And then we'll be hosting some final review sessions in the coming week or something like that. So yeah, thanks for a great year, guys. Appreciate the project support and stuff. So good luck in the project. If you have any questions, feel free to reach out, and I'll see you guys at the reviews, hopefully.